Good morning to one and all. My name is Raj Shekhar AS, Assistant Professor, Department of Physics, Government First Grade Women's College, Tumkur. So, now I take the class, final year BSc 5th Sem, Astrophysics. Today we are discuss about stellar parallax. Before that, what are the learning objectives? To study the distance of the star from the Earth in the universe. And session outcomes are explain the parallax, identify the units of stellar distance. Before we have discussed about the stellar parallax, earlier class we have discussed about the basic different units of stellar distance. So in astrophysics, the study basically we studied about the physical properties of the celestial bodies like star. What are the physical properties? We have discussed about luminosity of the star. What is the luminosity? How much of the energy radiated per second per unit area? What is a star? Stars are the celestial bodies. Galaxies are group of the stars. You know that basic concept. And we have studied about different units of stellar distance. Light year, parsec, and astronomical unit. The distance traveled by a light 1 year is called light year. The distance at which a star has parallax for second is called parsec. 1 parsec is equal to 3.26 light year. Okay, what is that? Parsec. Parsec is the distance at which a star has to be parallax per arc second. Astronomical unit. Astronomical unit is the average distance between the sun and earth. The average distance between the sun and the earth is called astronomical unit. So 1 is equal to 1.5 into 10 raised to 11 meter. Okay. So we know the basic concept. Today, so what is a stellar parallax? Stellar parallax is the distance of the star. We see the figure. The distance of the star measured in terms of effect is called parallax. That means the apparent shift in the position of the object. When it is observed from the two different points means in the Earth orbit is a point P1 and P2. It's called as P1 and P2. The star sun is called S1. The sun is called S. Consider star S. You see the figure. There is an Earth orbit. So when it's around the observer from the two different points, Earth 1, Earth 2, that's called P1 and P2, is called heliocentric parallax or stellar parallax. What is that? It is observed from two different points in the Earth orbit around the sun is called parallax or stellar parallax. Stellar parallax is defined as an angle theta p. It's called theta by 2 in seconds of an arc subtended at the star by mean radiation of the Earth orbit around the sun. It is determined the distance of the star from the Earth used to diameter of the Earth orbit. The baseline. This is the baseline diameter of the Earth orbit. So to this derive this 1 parsec or the parallax per second, arc per second, consider a star S. Consider a star is called S1. observed from the position P1 and P2. Earth 1 or Earth 2, or you take the P1 and P2. So first you observe the P1, Earth, first position. After the 6 months, you observe the star P2 or Earth 2, the apparent displacement of the position, or it is an apparent displacement of an object due to the change in the observer point of view, is called stellar parallax. If capital T is the distance between the sun to star, okay, and small d is the distance between the earth to the star, r is the capital R is the radius of the earth orbit, radius of the earth orbit around the sun, and the sun is called as capital R. Now from you take the triangle earth S star, this is called P1 S S1, theta is very small. So take the sine theta. Sine theta is equal to R by D, R by T. It's called R, D, R by D. So theta is equal to R by D. This is question number 1. We have to calculate the radians. Pi radians. Pi radians means 180 degree. 1 radian is equal to 180 degree by 5 into 60 minutes into 60 seconds. Calculated. An answer 206,265 seconds. Arc of. So 1 second of arc is equal to 1 by 206,285 radians. By converting the theta radians in second, so d is equal to 1 by theta. So theta, sin theta is approximate to theta. So d is equal to 1 by t, d is equal to 1 parsec. D is equal to 1 parsec. Then thus parsecs is a distance at which the radius of the earth orbit. What is it? Then thus parsec is the distance at which the radius of the earth orbit, 1 AU. Already 1 AU, angstrom unit, angstrom unit. Thus the parsec of the distance at which the radius of the earth orbit. So the distance at which star has the parallax of arc second. Calculate the arc second. We know that what is a stellar parallax? It is an apparent displacement of an object to change the observer point of view is called stellar parallax. The apparent position or apparent displacement of the two stars is one. So the sun and star. Observer point of view. So theta is equal to d is equal to 1 by theta. So we take d is equal to 1 arc per second. It's called parallax. Okay. So already we know that what is a light year and parsec are astronomical unit. Astronomical unit. Okay. So I'm taking the reference. So Dr. N. Sundarajan, College Physics, and Dr. Ramkrishna, Dr. Maleshappa, Dr. Prem Kumar HB, Fundamental Physics, and Semester Sahu. Thank you for watching the video.